So it's my distinct pleasure to introduce to you today Jon Stika. As most of you have been hanging around the soil health movement for a while, know it began not from decrees on high, but as a grassroots movement. This movement was fueled, as you've already heard today, by boots on the ground, field people working in collaboration with highly innovative farmers. Jon has been one of those people. With a love for the land, concern for farmers, keen observational skills, and an understanding of ecology, Jon was a pioneer in articulating and applying the principles we use today to guide soil regeneration. With humility and vision, Jon persisted when many told him that won't work here. With compassion and determination, Jon and his fellow pioneers persisted with learning from both their successes and failures, things researchers continue to scramble to quantify and understand. Jon has written a book, which he'll tell you more about in a few moments, summarizing what he learned throughout his NRCS career. I encourage you not only to get a copy and read it, but share it with someone else. Jon, your vision and work has swelled to a growing number of people. This is the second year in a row this summit is sold out. We are but a small part of this greater movement. Thank you for all you've done. It's our intent to carry this work forward. Please help me thank and welcome Jon Stika.
Everybody hear me all right? Thank you. Thank you, Ken. I knew you'd probably pull something like that. But thank you very much. It's really, wow. When I look at the cross-section that we have here today of people, farmers, agencies, I was talking to Ken earlier that he and I were both part of, as he said, pushing a rope up the hill to the soil health, trying to get people to even listen to us. First time I talked about this was in 1992, and it was kind of rough. I had a PowerPoint presentation. I got to my second slide, and I said something about tillage was bad for the soil, disturbance was bad for the soil. And that was the end of my prepared presentation. It turned into a discussion, which was excellent. But by the time it was done, I thought, okay, these people are either going to think I'm crazy, or there's going to be a few people that are going to start to think, maybe he's on to something here. And a little story with that story, afterwards, the people who came up to me and said, I think you're on to something, were all the farm wives. It wasn't the guys, okay? And I thought that was also interesting, that they recognized we're degrading this. We need to restore this. And I think the guys recognized it, but they weren't going to say it to me. So, but anyway, it's been a long trip, and now, as Ted mentioned to me, we're chasing a snowball down the hill. Now everybody's interested, or getting interested, and wanting to learn more. So when I retired from NRCS here a few years ago, people asked me, okay, Jon, before you leave, did you write all this stuff down? I said, no, I didn't. It's in PowerPoint, or it's in this, or it's in that. So I decided to write it down and capture the principles that I understood at the time were important and that really helped restore the soil, and make it approachable so anybody could read it, understand it, get the basics, and then become a student. Because we all have to be students of this if we're going to get anywhere. You can't just read one book, you can't just hear one presentation and say, okay, I got it. There's a lot to learn, there's a lot to understand, and I hope everybody continues to be a student. So with that, I've crisscrossed the country over the years with NRCS, so that helped me a lot, as I got to talk to a lot more producers in different places and see what they were dealing with and how they could solve the problems that they were facing. And it kept coming back to these principles. So the principles apply anywhere on the planet, really, that there's soil. So when I put this presentation together, I thought, you know, this really is the future of agriculture. We were having some discussions last night about how long do you want to farm? And the whole idea of being sustainable is how long are you going to be in business? And I drove from North Dakota, drove across a lot of Minnesota, saw a lot of bare ground. And that hurt. Because in my part of the world, I'm not bragging, but in my part of the world, I would challenge you to drive around and find some bare ground right now. Because we have no snow cover. So it'd be easy to see. So there's a lot of work that needs to be done, a lot of understanding that needs to change. So we'll get rolling here. See if I can hit the button instead. Oh, maybe you didn't turn it on. It works better when you turn it on. So why did I write this book? I have two things listed up there. There was really three. So the one that I don't have listed up there was kind of related to the second one, the frustration of the status quo of agriculture. In that, I didn't want somebody to hijack the term soil health and start using it to sell stuff. And it's okay if people do that, as long as they really understand what soil health is. And, you know, I don't have a problem with that. The other thing was I saw producers constantly struggling with the same things. With NRCS, all we were doing was chasing the soil down the hill or chasing it downwind. So what? That wasn't the problem. Erosion's not a problem. And the first time I said that in an NRCS meeting, I almost didn't get out of the room. That's not a problem, that's a symptom. That's a symptom that the soil is not functioning. Okay, so we need to sort some of those things out. So the purpose in writing this book was to get this down so that people can approach this subject and understand it and get somewhere with it and really know what soil health is supposed to be about. So as we start sorting things out on the bottom of this slide, I have things that could be goals, they could be tools, they could be symptoms, they could be problems. It depends. We all like to talk about tools. That's the fun stuff. Okay? We all like to fight over tools. Oh, this drill is better than this drill. This herbicide is better than this herbicide. You know, all those things. Those are tools. You have to be willing to look at all the tools and use the tools, but you have to know what the goal is. If I gave everyone in this room a pile of lumber and a toolbox full of tools, what would be your first intelligent question? What are we building? Okay? You need to ask yourself, what am I building? Am I building my soil? Am I restoring my soil? Am I building my soil back up? What am I building? If you don't know what you're doing, you don't even know what you're building, how are you going to get anywhere? And if you don't understand how to use the tools, you could build something, you could hurt yourself. Okay? So we need to sort those things out and really understand. And how many of you have been around a 3-year-old? Okay, what questions they ask all day long? Why? Why? And someone told me you have to ask why up to 5 times before you get the real answer. Okay? I have soil erosion, this problem of soil erosion. Why? Let's take water erosion. Why? Well, because the water's running off and it's taking the soil with it. Why? Because the water's not going into the soil. Why? Because I don't have stable soil aggregates to allow the water to go into the soil. Why? Because I managed it in a way that I don't have stable aggregates. Why? Because I didn't know any better. Okay? I've had that discussion many times. But once you know better, now you need to do better. And that's where I see this movement is getting to the point now where people are starting to know better, and so they're starting to do better. They're not just ignoring some of these things and saying, yeah, whatever, I've had a little bit of erosion, or those kind of things. So think about those things. Your goal is a desired condition. So think about that. Write some of that stuff down. That's helpful. And tools can be applied to get you in the right direction. All right, change. That's the other big thing. That's really what a lot of this is about. And change includes uncertainty. And people, we look at, as humans, we look at change as a fear that we're going to lose something. Okay? We're afraid of it. It has a negative connotation in the brain. That's how we're wired. We resist change because it's probably going to be bad. It's going to be different than what I'm doing now. It's going to hurt. Okay? So, when you look at it from a psychological standpoint, people would rather be unhappy than uncertain. So, think about that as well as you start to think about what you might have to change. So, there needs to be a paradigm shift to really understand how the soil functions. And it's a biological system. Okay? I didn't make that up. I didn't discover that. It's just the way it is. We were talking last night, that's why I chose a soil owner's manual for the title of my book. We were talking last night, I said, if you look in the owner's manual for a tractor and it says put in diesel fuel, it runs really good on diesel fuel. But if you put gasoline, or you put 2-cycle oil, gas in it, or ethanol, it might run for a little while until it burns itself up or destroys itself. But it runs a lot better if you just follow the owner's manual. So the owner's manual is the principles of soil health that are based on what nature has been telling us, showing us is the way the soil is designed to function. It's a biological system. It's not a chemistry set. It's not just a bunch of dirt. It's a biological system. So once you wrap your mind around that and manage the soil to be a biological system, then all these things change. Everything changes. Everything starts to function again. So, we need to stop treating symptoms of dysfunctional soils. I mentioned erosion. And we really need to just restore the soil. When you look at your own health, and by the way, how many things can you think of that are more important than your own health? If you're not healthy, it doesn't matter. It doesn't matter if you're not healthy, as long as you got a lot of money, or as long as whatever. No, there's nothing more important than that. You can't think of anything more important than whether or not you're healthy. So, to look at the soil and say, let's stop treating these symptoms and let's solve this problem. Let's get the soil to go back to doing what it was supposed to be doing in the first place. And we can do that while being profitable. And I would argue that unless you're restoring your soil, you're going to go broke. It's a matter of time. I'm watching it happen. I'm watching it happen right now. And I'm hoping that people understand that they need to restore their soil health before they lose all their equity and go broke. Because it's happening. So these aren't mutually exclusive. It's not going to cost you a whole bunch of money to restore your soil health. You can do it and save money and be more profitable at the same time. So, and conservation practices do not restore soil health. Understanding restores soil health. So again, conservation practices are tools. It's the understanding. We have all these groups here today. We have producers that are doing it, all these other groups that together can all put this picture together, apply these principles, and grab these tools. These conservation practices that's the toolbox. To grab these tools and figure out, when do I use this tool? How do I use this tool? How do I achieve my goal? Oh, got a little trigger happy there. And we often must unlearn some things. I have a degree in soil science. So I go to work for NRCS as a soil scientist, as an agronomist. I've had a number of different jobs with them over the years. But it was at a certain point that I realized I'm a soil scientist. I don't know how the soil functions. And that was terrible. Like, I'm a doctor, but I don't know anything about how your body functions. I can name all the bones, but I can't figure out what's wrong with you. Oh, great. That helps me a lot. You know. So as a soil scientist, I could classify the soil. I could tell you what kind of soil it was. I had no idea how it functioned. And I thought, that's ridiculous. It's sad. So I set out to unlearn some things and learn some new things until I understood, how does this really work? How is this really designed to work? So, and this is part of a lot of what I talk about. What is soil health and why should I care? And it's really about the capacity of the soil to function. And so I tell people, okay, the only people that should care about soil health are people who drink water and eat food. Everybody else doesn't need to worry about it. Because where else is it going to come from? How else is this going to work? So by doing so, you can become more profitable, maybe avoid being regulated. And I saw some of the initiatives that Minnesota has to help people certify what they're doing. So if and when the regulator shows up, you can say, hey, yeah, you look at my farm, everything is cool here. I've got my soil working again, I don't have runoff, etc. And we can leave the soil better than we found it. Okay? It's been degraded. It's been degraded for a long time out of ignorance. You know, people didn't degrade the soil. Your dad, your grandpa, they didn't degrade the soil because they thought that was a good goal. They didn't know any better. They worked with the information they had at the time, did the best they could, just like all of us do. But now that we know better, we need to do better. Okay, so all of you have heard the expression, if mama's not happy, nobody's happy. Okay? The soil is mama nature, basically. If the soil's not happy, nothing's going to work. Your hydrologic cycle isn't going to work. Your carbon cycle isn't going to work. Your nitrogen cycle isn't going to work. And if those don't work, then you're going to have to irrigate. You're going to have to apply fertilizer. You're going to have to provide a whole lot of inputs that all cost money. It costs time, energy, and money. And so you keep putting these inputs into the system to keep the system running. As soon as you stop those inputs, the system is just going to sputter down and die. A functioning soil doesn't need all those inputs. Okay? I got a lot of trouble when I worked for NRCS. I got a lot of trouble one time because I said you don't need fertilizer. And I had a lot of explaining to do, but I'll say it again, you don't need fertilizer. Commercial fertilizer is a crutch that you need if your soil's not functioning yet. And the people I talk to that have been applying these principles for many years, I encourage them to back off on the fertilizer. Just keep backing off on it until you're not using any. We have a study that we're doing at Dickinson at the Research Center right now that included soil testing. It's a diverse crop rotation, no tillage, grazing. Some of the crops are cover crops grazed with livestock. And part of the protocol was to do soil testing and apply according to soil test. So we got a few years into it, do the soil test. Soil test says you don't need any nitrogen. So we haven't applied any fertilizer on that study for 3 years now, because the soil doesn't need it. The atmosphere is 70-some% nitrogen. There's plenty of nitrogen. And there's plenty of organisms that will fix that nitrogen, not just ones that live with legumes. There's a lot of other ones that will fix that nitrogen. You have to make a home for them. You have to make a place for them to be able to do that. If the soil is a hostile environment for them, it's not going to happen. You have to go buy fertilizer. So, again, it's a biological system. And I've probably said that 20 times. I'll probably say it 100 times more before we're done. But this diagram, some of you have probably seen. A guy stole that from the soil biology primer. I did. I like this diagram because I can use it to torture people about 7th grade science. And I'm a scientist. I admit it. I'm a super nerdy scientist. And I drive everybody nuts with this stuff. But it's important. So when you look at this diagram, you have the sun, you have green plants, you have the soil, and you have the soil food web, all the things that are supposed to live in the soil. The key with this whole thing is the sun and the capture of that energy. That's really what agriculture is about. We have this free energy source. How much of it can we capture and utilize and put to work for us? So we have green plants, and the green stuff in the plants is chlorophyll. Let's check and see if we're still awake. And chlorophyll, when the sun shines on it, does what? Another big word. Photosynthesis. Okay, it's all coming back to you now. What are the products of photosynthesis? Too early in the morning for that? I see a lot of young people here that really aren't that far away from being in school. Okay. Oxygen, sugar, carbohydrates. Okay. Where does the carbon come from that these plants make carbohydrates with? From the air. Okay. It doesn't come from the soil, it comes from the air. So they're pulling CO2 out of the air, combining it with water, making carbohydrates, which are sugars. And any given plant will exude 1/3 to 1/2 of those sugars out into the soil through their root system. Okay? I didn't know that when I graduated from school. They'll exude 1/3 to 1/2 of those sugars out of their root systems. That's a lot of money. That's a lot of their currency that they're putting into the soil to support all of those organisms. We all work, but So what do you expect your soil to do? What functions do you expect your soil to perform? And they create this long, awkward silence.
Don't all talk at once.
Until, yeah, don't all talk at once. What do you expect? Has anyone ever asked you that question before? That's why you're all stunned. Nobody ever asked me, what do you mean with my soil? What do I expect my soil to do? What are you trying to do out there?
Produce a saleable crop.
Okay, you're trying to grow stuff, right? Trying to grow stuff. So, if you're trying to grow plants, what do those plants need to grow? I told you this was going to be painful. This might be higher than 7th grade science now. What do those plants need to grow?
Water, sunshine.
Okay, water, nutrients. All right, that wasn't so painful. So what we expect the soil to do, we expect the soil's role to be, is to infiltrate and store water, to supply nutrients to those plants. That first one is huge. There's a lot of acres of agricultural soils in this country, around the world. That doesn't happen. That's not happening. Okay? You have tile drainage in this part of the world? Okay, I don't where I'm at, but what good does it do to have tile drainage, to have tile drains down 3 or 4 feet in the soil when the water can't get into the soil at the top? The water's still going to sit there. It's still going to sit there. You don't want it to sit there. You want it to go down through the soil, into tile, and out of the way. I see acres and acres of stuff that's tile drained, and the water's sitting out there. Because the soil does not have stable aggregates, and the water can't infiltrate the soil. So you say, I don't need soil health. You know, I got good soils, I got tile drainage, whatever. That's fine. You spend money on tile drainage, you expect it to work. You don't have stable aggregates and porosity of the soil, the water can't get there. So, but we have to infiltrate that water, or the plant won't be there for the plants to use. It runs off or evaporates, it's gone. Okay? And supplying nutrients, that's the role of biology, feeding those plants. So, all of this comes back to stable soil aggregates. Does everybody know what an aggregate is? Okay? You better know what it is first. It's a $20 word soil scientists use for a lump or a clump of soil. Okay? Those lumps and clumps of soil are held together by biological glue. When I took soil physics in college, soil is held together by clay and clay colloids and all. Yeah, some. But the real glue that makes aggregates stable when they're wet, because the soil does get wet sometimes, right? What holds them together when they get wet is biological glue. Those biological glues are also food to other things that live in the soil. So if you're not continuously making those glues and replenishing those glues to keep your aggregate stable, they're going to fall apart. If they fall apart, the water's not going to go into the soil. And now you have one big thing that the soil is supposed to do that it's not doing anymore. Okay? So, if you ask the soil microbiologist, 90% of what happens in the soil, what we expect the soil to do, is driven by soil organisms. Okay? So there's an aggregate. You can see the sand, silt, and clay stuck together. And I told too many stories, so I won't get through everything. I might start moving a little faster. When I was at another meeting of farmers, run by farmers, they said, well, you got 5 minutes left, we're going to give you this sign. When you got 1 minute left, you don't want to see that sign. So, but they make, these organisms make lots of sticky substances that hold the soil together. These are some soil aggregates that I dumped out of a bucket after I washed some soil off my carrots in my garden. So they were sloshed around the bucket for quite a while before I dumped them out. They were still there. They were still stable. Okay. So, rhizospheres is the area right around the root where all the sugar is coming out, where all the organisms are active. Okay, that's where everything's going on in the soil. If people talk about nutrient availability, pH, all that in the bulk soil, it really doesn't matter. It matters there. If you have the biology there, they'll manage all those things for you. Okay. So, carbon is the glue, the energy. I've already mentioned a few of these things. I always do that. I get way ahead of myself. Very little of the nitrogen fertilizer you put in the soil actually ends up in the plants, by the way. It's the response you get from the fertilizer. It's not that all the fertilizer is going into the plant. So let's get the principles up here. I only have 4 principles that I've used. There's some have 5 principles, some have 10, some people have 10 principles. I don't care. I'm not going to argue about how many principles there should be, because all the principles that I've seen that people have come up with in addition to the 4 that I have do contribute to soil health. So if you want to consider them a principle, cool. I don't have any problem with that. But these are the main ones that create the most favorable habitat for the soil food web. That's what you're really trying to do. You need to create the most favorable habitat possible for the soil food web. If you minimize the disturbance, maximize the diversity of plants that feed those organisms, keep living roots in the soil as much as possible, which where cover crops are starting to come in, and keep the soil covered all the time, you make a really nice place for them to continually make those glues that hold the soil together, continually feed the plants, keep the soil functioning. So in a little more detail, there's different types of disturbances, and again, you have to think about it biologically. What disturbs those organisms in the soil? You can disturb them physically with tillage, and tillage can only break aggregates into smaller pieces. You can't build aggregates with tillage. It's impossible. And one other thing to think about, maybe not right now, but write it down, you can think about while you're driving home. There's no tillage operation that directly benefits the soil. There's no tillage operation that directly benefits the soil. We've been doing this for 12,000 years. Okay? Think about that on the way home. We do tillage for other reasons, but it never directly benefits the soil. Okay? That's a good point of discussion for later. Plant diversity. Each plant produces different kinds of sugars at different times, so you have a very diverse diet of what the soil organisms are being fed. You aren't going to do well with just one plant, the sugars from one plant. And that's, getting back to the range of people are ecologists. I love them because they're ecologists. They look at the whole picture. They understand diversity. They understand rhizospheres. Okay? Which is what living roots are. So here's a lot of opportunities to have living roots out there. Cover crops, perennials, winter annuals, biennials, different crops in your rotation. Okay? Lots of opportunities here. This is a drawing that I had somebody make for me. And she's sitting over there in the corner. But I said, I want a picture that shows the plant handing money to the soil organisms, and the soil organisms bringing the plant plates of food. Because that's what's going on down there. And then the rest of the organisms are all, playing their role. I said, that's what's going on there. This plant is taking solar energy and it's handing them money and they're bringing the plant plates of food. So we have to keep the soil covered just physically to protect it. It's also a habitat for soil organisms. Okay, and benefits of managing. North Dakota State University, if you're no-till, your system has been no-till for at least 5 years, you take a 50-pound nitrogen credit. It's a lot more than that if you diversify your rotation. Then you can take a 200-pound nitrogen credit, whatever. You don't need nitrogen fertilizer anymore, basically. It's very possible. It's very doable. Improved soil aggregation for water, fewer weeds and diseases. And then I was glad to see on the program somebody's going to be talking about economics, because it's all about economics. If you manage the soil the way it was designed to function, you're going to be profitable. It's just the way it is. So how do we know if soil health is improving? We can measure some of these things. We can look at our aggregates. We can see if the water is infiltrating or not. We can do some really elaborate DNA, RNA, phospholipid fatty acid tests to see what biology is living in there. Some really cool stuff we're doing now. Simple aggregate stability. Take a chunk of soil off the surface, let it dry out, drop it in some water, see how long it holds together. If it holds together more than 30 seconds, that's not bad. If it holds together for 3 minutes or more, that's pretty good. Okay. So down the road, we have fewer weeds, less inputs, herbicides, fertilizer, whatever, earthworms. A few years ago, I dug a cubic foot of soil out of my garden. My kids gave me a hard time about that. Dad, you know, when I know that would do something like that. And count the number of earthworms. They were 75. There's probably more now. So that's a lot of worm poop. You know, there's a lot going on. And they're a very good indicator because they're near the top of the food chain of the soil food web. So the rest of the food web is there. You have lots of food to eat. You have lots of earthworms. So soil health is the capacity of the soil to function. And it's a biological system. And if you want to know what you need the most to fix your soil, it's plants. Okay? It's seeds. Seeds should be your big input thought. That's what you need out there, to more plants. As many different kinds of plants as you can get out there. And yes, our soils have been degraded, but they can be restored. Okay? We know how to restore them now. So there's no excuses. we know better. So now we have to figure out how to do better, how to convince people to do better, and start to look at some of these things, to experiment with some of these things. So soil health is understanding how the soil is designed to function. And then you can ask yourself, how does your farm reflect the way you manage your soil, how well you manage your soil? And this was just a group that farmers I work with, doing a little infiltration demonstration and things in the field. But that's how it works. Get them to change their thinking and start to experiment and share what you know, and that's what I see a lot of happening here. So, hey, I finished on time.